In this video, we're going to go over the math-based practice problems for Chapter 10. So this first one we're starting with, we see Pedro, who's operating as a single price monopolist on Huntington Beach. So Pedro owns the only rental bicycle business in that area, and we're given his demand curve as quantity demanded equal to 1,000 minus 5 times the price, where the number of bicycles rented each week is represented by quantity, by Q, and his total cost is 40Q. If we assume that Pedro cannot price discriminate, we want to find his profit maximizing level of output and his profit maximizing price. So here we're going to have, just again, a basic single price monopoly. So we're going to start by taking his given demand equation and solving for his inverse demand equation. So we're solving for the price. So we're going to add 5 times the price to both sides. That's going to give us 5 times the price plus quantity equal to 1,000. And then we're going to subtract quantity from both sides. So we get 5 times the price equal to 1,000 minus quantity. And then lastly, we'll divide both sides by 5. And that will give us price equal to 200 minus quantity over 5. Okay, so that is his inverse demand equation. From there, we're going to find his marginal revenue equation. And since he's a monopolist, we know that his marginal revenue curve is twice the slope of his demand curve. So we're just going to double this 1/5. That's modifying quantity. So we'll have marginal revenue equal to 200 minus 2 over 5 times quantity. And we know that monopolists produce where marginal revenue equals marginal costs. So we have marginal revenue, but we don't have marginal costs. So if we go back up to our givens, we can see that Pedro's total costs are 40Q. And so if we take the derivative of total costs with respect to output, that gives us marginal costs. So we know his marginal costs then are constant at 40. So we're just going to set our marginal revenue, or Pedro's marginal revenue, 200 minus 2/5 times output equal to 40. Okay, and from there we're going to solve for output, right? How much output maximizes Pedro's profits? Okay, so we're going to add 2/5 times quantity to both sides. That gives us 200 equal to 40 plus 2 over 5 times quantity. From there, we'll subtract 40 from both sides. So we get 160 equal to 2 over 5 times quantity. And then we'll multiply both sides by 5 halves, right? The inverse of that fraction modifying quantity. So we'll have 5 halves times 160 equal to quantity. And 2 is going to go into itself 1 time and into 160 80 times. So we have 5 times 80, which gives us 40, and then 400, excuse me. 5 times 80 gives us 400. And so the profit maximizing output for Pedro as a single price monopolist is 400 bicycles per week. And then we want to find the price that he charges. So that price is going to depend on the demand curve. He's going to mark up as high as he can. So we're just going to substitute for quantity into the inverse demand equation that we previously found for Pedro. Okay. So we'll have price equal to 200 minus 1/5 times quantity, and quantity here is 400. So we have 400 divided by 5. That's going to give us 80. And then 200 minus 80 gives us a price of $120. All right. So as a single price monopolist, Pedro's profit maximizing output is 400 and his profit maximizing price is $120. Okay. Next, we're going to look at part B. Part B says, okay, now we're assuming that Pedro can price discriminate, and in fact, he can perfectly price discriminate, right? So we want to keep in mind, what does that mean when we say he can perfectly price discriminate, okay? We want to know how many bicycles will he rent and at what price. So perfect price discrimination means that he is going to charge every single consumer their exact willingness to pay. So in terms of the price, there will be no single price, right? Because he's charging every consumer exactly what they're willing to pay. So we can say each consumer pays the price that equals their willingness to pay. Okay, so that we know there's no single price, but we do want to know how many bikes he will rent out. And we know from the lectures that perfectly price discriminating monopolists produce where price equals marginal cost, right? They look like a perfectly competitive firm. So what we're going to do is set Pedro's demand curve equal to his marginal cost. So we'll have 200 minus 1/5 times quantity equal to 40. And we're just going to solve for quantity. So we'll add 1/5 times Q to both sides. That gives us 200 equal to 40 plus 1/5 times quantity. From there, we're going to subtract 40 from both sides. So that's going to give us 160 equal to 1/5 times Q. And then we're going to multiply both sides by 5 to get rid of that 1/5 on quantity. So we get 160 times 5. So that's going to give us 800 is his profit maximizing amount of bicycles rented each week. And he's not going to charge one single price, right? He's going to charge everyone their willingness to pay. So that's our answer for part B. Moving on to C, it asks us to compare how the distribution of surplus changes when Pedro goes from being a single price monopolist to when he can perfectly price discriminate. Okay, so let's go ahead and draw this market just so we can visualize what's going on here. So Pedro again is our monopolist. That means he's going to face a downward sloping demand curve. And we know that his choke price that he faces is 200 because our inverse price equation, inverse demand equation is price equal to 200 minus 1/5 times quantity. So when quantity is 0, the price is 200. So that means that $200 consumers are not willing to pay for the bicycles anymore. We also know that his marginal cost is constant at 40. And we know that his marginal revenue is twice the slope of his demand curve. Okay, we found that where marginal revenue equals marginal cost, we have a quantity of 400. And where price equals marginal cost, the quantity is 800. We know that when Pedro is operating as a single price monopolist, he charges $120. And when he is operating as a perfectly price discriminating monopoly, he charges everyone their willingness to pay. So we'll first start with Pedro as a single price monopolist and then move to him being a perfectly price discriminating monopolist. So let me see if I can copy this graph real quick. Copy, paste. Okay, so we're going to start with Pedro as a single price. And then we'll look at him as a perfectly price discriminating monopolist. So perfect price discrimination. Okay. So when he's a single price monopolist, we have some consumer surplus. Right? Consumers pay less than they are willing to. And that top triangle here is our consumer surplus. Producer surplus is the rectangle formed by the price line, the margin, and the marginal cost curve. And then dead weight loss is the triangle that shows the difference in surplus generated by a perfectly competitive firm and that produced by a monopolist. So here for Pedro, we have consumer surplus is equal to that triangle. So we'll have it equal to 1/2 times 200 minus 120 multiplied by the total sold, which was 400. So times 400 minus 0. That gives us 1/2 times 80 times 400. So that is 40 times 400, which is going to give us $16,000 for consumer surplus when Pedro is a single price monopolist. His producer surplus is the area of our green rectangle. So that'll be 120 minus 40 times the amount sold, which is 400. That gives us 80 times 400. So that'll give us $32,000 for producer surplus. And then lastly, deadweight loss. Oops. Deadweight loss now is going to be the area of that pink triangle. So 1/2 of 120 minus 40 times 800 minus 40, that difference between what a perfectly competitive firm would produce and what Pedro produces as a monopolist. So we get 1/2 times 80 times 400. That gives us 40 times 400, and his deadweight loss is symmetric to the deadweight loss in the market is symmetric to the consumer surplus, so it's 16,000. Okay. All right. Now let's look at when Pedro is a, whoops. Let's look at when Pedro is a perfectly price discriminating monopolist. I'm just gonna move this graph real quick. We're just gonna make it a little smaller. Let's see. Okay. How can I? Hmm. Okay, so now when Pedro is a perfectly price discriminating monopolist, he's charging everyone their willingness to pay. So he's walking the market down its demand curve, right? He's walking consumers down their demand curve. So he's going to sell every single bicycle up until that point when the last price that he charges is exactly equal to his marginal cost of providing those bikes. So in essence, what that means is he captures the entirety of the market as producer surplus. Okay, so that entire triangle formed by the marginal cost curve, the demand curve, and the price axis is producer surplus. So consumer surplus equals 0, deadweight loss equals 0, right? Exactly as much as produced by Pedro when he perfectly price discriminates as would be produced by the perfectly competitive market. And then his producer surplus is 1/2 times 200 minus 40 multiplied by the quantity traded, which is 800 minus 0. So we get 1/2 times 80, not 80, excuse me, 160 times 800. So we get 80 times 800, which is going to give us $64,000 as producer surplus when Pedro is a perfectly price discriminating monopolist. Okay. Looking at our next practice problem, now we're going to do an example with segmenting. So we have Camellia Grill, which has 2 locations, at least it did, it doesn't anymore, in New Orleans. The first one is in the Uptown area near the colleges there. And then the second is in the French Quarter, so downtown. So Uptown customers have demand that's different from French Quarter customers, meaning that Camellia Grill can segment these markets and charge different prices, right? But before we do that, what we're going to do is look at what price Camellia Grill would charge and what how much they would produce, as well as what their profits will be if they do not price discriminate, and then we're going to compare that to the situation where they price discriminate, okay? So first what we're going to do is add these demand curves together to get the total market demand for Camellia Grill's meals. So our total market demand is going to equal, let me rewrite that. So our total market demand is going to equal demand, the quantity of meals demanded uptown and the quantity of meals demanded downtown. So we're going to get, or in the French Quarter. So we're going to get market quantity demanded is equal to 50 minus the price plus 120 minus 4 times the price. Combining like terms gets us the market demand equal to 170 minus 5 times the price. From here, now, in order to figure out the price that they're going to charge and the amount that they're going to serve, we need to solve for Camellia Girl's inverse demand equation. So we're going to solve for that price. So we'll add 5 times the price to both sides and subtract quantity. So we'll get 5 times the price equal to 170 minus quantity. And then we're going to divide both sides by 5. So we get price equal to 34 minus 1 over 5 times quantity. Because Camellia Girl is operating as a monopolist, right? They are the only ones serving their types of food. We're going to solve for their marginal revenue, and we're going to do that just by doubling the slope on their demand curve, which is 1/5. So 1/5 times 2 gives us 2/5. So their marginal revenue is equal to 34 minus 2/5 times quantity. And we also need to know their marginal costs, which was given to us at the beginning. Both their marginal and average costs are constant at $6. So marginal cost is 6. Now we can set these values equal. So marginal revenue equals marginal cost. So we get 34 minus 2/5 times quantity. It's equal to 6. We're going to add 2/5 times Q to both sides. And we're going to subtract 6. Okay, so we get 28 is equal to 2/5 times quantity. Now we're going to multiply both sides by 5/2 to get rid of the constant on Q. So we get 5/2 times 28 is equal to quantity. 2 goes into itself once and into 28 14 times. So we get 70 is equal to quantity demanded on the market. So total, Camellia Grill is going to produce 70 meals. And now we can find the price that they charge. So their price is going to equal 34 minus 1/5 times Q. That's just their inverse demand equation. And we're going to substitute 70 for quantity. So we have price equal to 34 minus 1/5 times 70. So price is equal to 34 minus 14. And that's going to give us a price of $20. All right, so their profit maximizing price is $20. And total, they're going to produce 70 meals. Part B asks, how many meals will they serve at each location? Okay, so we know in total they'll produce 70, but we want to know how many go to the French Quarter customers and how many go to the Uptown customers. So we're going to use our demands that we were given for each segment of the market. So Uptown, we had quantity demanded equal to 50 minus the price. And in the French Quarter, we had 120 minus 4 times the price. So we're just going to substitute the price that we found in each of these. So quantity demanded Uptown is equal to 50 minus 20, and quantity demanded in the French Quarter is going to be 120 minus 4 times 20. So we'll get Uptown quantity demanded is equal to 30 meals. And then for the French Quarter, we're going to get 120 minus 80, which gets us 40 meals provided to the folks in the French Quarter. So total together, that's 70 meals, just like we found in part A, but we can see how they're distributed now. Part C asks what their profits will be. All right, so we're going to use their profit equation that we've been using. So we'll have profit is equal to price minus average total cost times output. All right, so here we're going to have that their profit is equal to their price, which we had at $20. Their average total cost is 6, and their total produce is 70 meals. So their profit, when they act as the single price monopolist, is going to be 14 times 70. And that's going to get us a total profit of $980. Okay. Now we're going to move to them price discriminating. So we're going to suppose that Camellia Grill, its owners, have noticed that they have distinctly different consumers uptown than in the French Quarter. French Quarter tends to be tourists more, whereas uptown tends to be locals. And so they're willing to pay different prices for things like red beans and rice, right? Those standard Cajun fare. And so they're going to price differently uptown than they will in the French Quarter based on the willingness to pay of each group of people. All right, so our uptown demand, we're going to start with that same demand equation of quantity demanded uptown is equal to 50 minus the price. And then the same one for the French Quarter. So we'll have 120 minus 4 times the price is going to get that quantity demanded in the French Quarter. And we're going to solve for the inverse demand equation in both cases. So for the uptown demand curve, I just added price to both sides and subtracted quantity. For the French Quarter, we're going to add 4 times the price to both sides and subtract quantity. Okay. So that gives us 4 times the price equal to 120 minus Q, and then we'll divide both sides by 4. So we get price equal to 30 minus quantity times 1/4. Okay. Next, we need to find the marginal revenue curve for each, and we're going to do that just by multiplying the constant on quantity by 2. So we'll have marginal revenue equal to 50 minus 2 times quantity produced uptown, or excuse me, quantity demanded uptown. And then for French Quarter, we're going to have the marginal revenue equal to 30 minus 2/4, which is 1/2, times the quantity demanded uptown. Okay. Now we can set each of these equal to the firm's marginal costs, which again are constant at $6. So uptown will have 50 minus 2 times quantity equal to 6. And in the French Quarter, we'll have 30 minus 1/2 times quantity equal to 6. And for each of these markets, we're just going to solve for output. So we're going to add, in uptown, we're going to add 2 times quantity to both sides and subtract 6. So we have 50 minus 6 equal to 2 times quantity. From there, we're going to simplify. So we get 44 equal to 2 times quantity. And then divide both sides by 2. We're left with 22 meals produced uptown. And then we're going to do the same for our downtown market. So we will add 1/2 times quantity to both sides and subtract 6. So that's going to get us 24 equal to 1/2 times quantity. And then we'll multiply both sides by 2 to isolate that quantity variable. So we get 48 meals produced in the French Quarter and 22 produced uptown. So you can see that the distribution of meals has changed. Now more meals are going to tourists and fewer are going to locals uptown. What we want to do next is figure out what price Camellia Grill charges for each market. So we're going to use the given demand equation for both and substitute for the quantity that we found. So uptown, that's price equal to 50 minus quantity. And then for the French Quarter, that's going to be price equal to 30 minus 1/4 times Q. So substituting for quantity uptown, we get price equal to 50 minus 22. So that gives us a price of $28 for these meals. And then for the French Quarter, we're going to get price equal to 30 minus 1/4 times 48. 4 goes into itself once and into 48 12 times. 30 minus 12, that's going to get us 18. So the price in the French Quarter is going to be $18 and uptown it'll be 28. Okay, so you can see that the French Quarter tourists are being charged a lower amount and having more meals sold, whereas uptown they're being charged more and having fewer meals sold. So next we want to evaluate whether or not price discrimination increased Camellia Grill's profits or not, right? Which pricing scheme essentially is better for them as a firm. So we already found that when Camellia Grill operates as a single price monopolist, they earn profits of 980. So now we want to see what they earn when they price discriminate. So we're going to see that their total profit is going to equal their profit that they earn from their uptown sales and their French Quarter sales. Okay, so we'll have profit uptown is going to be equal to the price charged uptown minus average total costs times the quantity sold uptown. And we're going to add to that the difference between the price charged in the French Quarter minus their average total costs times the quantity produced in the French Quarter. So we're going to get 28, that is supposed to be 28 minus 6 times 22 plus 18 minus 6 times 48. All right, simplifying, that's going to get us 22 times 22 plus 12 times 48. All right. 22 times 22 is going to get us 484. And we're going to add to that 12 times 48, which is 576. And so their total profit from price discrimination is going to be $1,000, $1,060. And so profit from price discrimination exceeds the profit from the single price monopolist. We can maybe do single price monopolist, which is equal to, I believe it was 980. And so the difference is going to be 1,060 minus 980. So that difference overall is $80. Right. These are problems 1 and 2 here that we've just done, covers the forms of direct price discrimination. I'm going to stop the video here, and then the next video will go through all the practice problems for indirect price discrimination.